Good afternoon, everyone. My name is Tim Yeager, and I manage the vertical markets at Tarana Wireless. We will start in a couple minutes. I just want to give a couple more minutes to let people join and get situated. Thank you. Good afternoon, everybody. My name is Tim Yeager. We'll be starting in about a minute, just letting some other people join. Good afternoon, everybody. My name is Tim Yeager. I run the vertical markets for Tarana Wireless. And today we're going to have a discussion about next generation fixed wireless access in the tribal communities. While we have this presentation, any questions that you have, if you type them into the question box, I will be more than happy to answer those at the end of the presentation. Today, we're going to go through what are some of the requirements for tribal networks. A brief overview of who Tarana Wireless is, what makes us different from traditional fixed wireless access networks, and how we are addressing the requirements of the tribal needs. A brief roadmap, examples of deployments that are out there, and questions and how to engage Tarana. The most important piece is your WinncOm account executive. If you just reach out to them, they can track us down wherever we are. These are some basic requirements for some of the tribal networks that we are deploying out there. This is not an exhaustive list, but all these networks require all of this. We're going to start off with reliability and durability. They come from the same types of needs. The people who are deploying the tribal networks and the tribes themselves do not have an extensive workforce that can constantly be supporting, building, replacing radios out there. So the radios have to be reliable, and then they also have to be durable. So they have to last for an extended period of time. They can't be just replaced every couple of years out there. And in some of these networks, they are mission critical communications, whether it be like a energy oil field type of deployment where an outage can actually result in a fine. So again, reliability is incredibly important. Ability to work in harsh conditions. Everybody's radios work fantastic in the labs, but we don't live in a lab. We all live and work in the real world. A lot of these deployments that we're talking about are either going to be in very warm, hot areas or very cold areas. So the radios that are being deployed have to be able to work in these harsh conditions. Ease of deployment. You have limited, the people deploying these networks have limited resources to deploy network assets and to maintain and to upgrade the network access. So these have to be easy to deploy. If the radios aren't easy to deploy, then it is actually detrimental in a lot of cases because you can't actually support the networks that you're building out there. So ease of deployment is very important. Ability to manage remotely. Having to go to a site to plug into a radio and see what is wrong with it and manage it is not ideal. So you have to be able to manage these networks from a centralized or multiple locations out there. Increased demand for data. There is an ever-increasing demand for data, both commercially and on the consumer base. Everything is starting to be much more data-driven than voice on networks. You know, you have streaming of videos, you have gaming networks, plus a lot of the applications that are being deployed out there and they can be used by the tribal communities are very data heavy. And then security. You have these radios and these networks have to be secure, especially with all of the latest security breaches that are in the news almost on a daily basis now out there. So who is Tarana? We're a fiber quality fixed wireless broadband manufacturer. Been in business 14 years with over 400 million invested in R&D over that period of time. And we started general availability and shipping of this generation of product in October of 2021. We have well over 28 patents and more still pending on there. Existing gear that is being shipped right now is 5 gigahertz and 3 gigahertz of CBRS band, with 6 gigahertz coming out later this year. G1 or Gigabit 1 was designed from the ground up. So we do not reuse either the Wi-Fi chipset or the 3GPP chipset. And we'll get into reasons for that later on. We have well over 200 deployments since October 2021. And when we're talking deployments, we're not talking pilots. We probably have about the same number of pilots out there. And last week, we had 3 networks that actually moved from pilots over to full functioning networks that are out there. We're designed in the US and we qualify for Made in America, which is important if you're going after any of the grant funding that is out there. So the market that we're going after is the $43 billion in broadband funding for underserved communities out there, or BEAD funding. So most of the tribal communities will qualify for this funding out there. They just need to apply for the grants when they are available. So we do not use any repurposed chipsets out there like 3GPP, which is the chipset that's in your cell phone, or the Wi-Fi chipset. We design our product from the ground up. And the reason is the technology of the 3GPP is excellent for what it was designed for, but when you start to modify it so it works for fixed wireless access, it does have some inherent problems. And the same thing with Wi-Fi. So you're probably starting to hear some talk about Wi-Fi AX and then also 6 gigahertz product. So this is kind of a mixture of terms that you see out there, where 802.11ax is a standard, where 6 gigahertz is actually part of a spectrum out there. So this is talking a little bit about not only Wi-Fi that is currently out there, but Wi-Fi AX. So again, it's designed on the same chipset, which is optimized for indoor APs, access points, so it talks to your computers and is a network on there. There's single beam forming, which is only at the access point. It is not at the remote client on there. It is not adaptive MIMO at all. So what that means is there's a different type of technology that is used in fixed wireless access that gives more streams of traffic to the end users and gives them better reliability on them. There's lack of support for near and non-line of sight. It is not designed for that. The existing spectrum that's out there, the Uni 1, 2, and 3, is congested. They don't have interference mitigation or immunity. In the new channels that are being added in the 6 gigahertz, the Uni 5 and Uni 7 are already being used by point-to-point networks. So again, you need the interference, immunity, and mitigation to be functional in that area. But the big issues with the Wi-Fi chipset is the amount of overhead that it uses and the fact that as you add more users, your part of the spectrum that you can use is less. So if it's only you on a Wi-Fi network, you get 100% of the traffic. There's 2 people, it's 50%, 3 a third, so and so on. So as you start to add more and more users, you get less and less throughput to the customer side. 3GPP is not the answer either. And the perfect reason for that, an example, is we've all been in a venue where we try to make a phone call or try to send a text or a picture or something. And even though we had 5 bars, we were unable to do that. And again, that's limited capacity on there. Asymmetrical signal strength. So you're getting the signal from the tower, but you're not being able to transmit to the tower the signal from the device. So it's not able to hear the information that's coming from the device. Again, minimal interference rejection, and it relies on a licensed spectrum. So what Tarana has done, we have an unlicensed version in the 5 gigahertz, and then we also have a CBRS version currently. We have the ability to cancel, not mitigate, but cancel up to 45 dB of our own interference that we are generating out there, and cancel 40 dB of interference from other radios and other networks that are out there. And again, keeping in mind, 3 dB of signal is basically doubling the signal every time on there. We have bidirectional beamforming. So we have intelligence on both ends of the link, and we are correcting the antenna and aligning the antenna for the optimal throughput and signal 5,000 times a second. We have symmetrical signal strength. So when you're transmitting from the tower to the radio, it's the same as if you are transmitting from the radio to the tower. So you don't have to worry that you're in a situation where you can hear the tower, but you can't talk to the tower as well. We also have spectrum reuse of one, which means that we can use the same parts of the spectrum in a 360-degree deployment, where other technologies are having to alternate channels so they don't cause any interference and can actually function in a 360-degree deployment. So again, we don't live in a lab, so we have real world challenges that we face anytime we're trying to deploy a network. Obstructions are one of them, and that's probably a large one. And it is a main reason that people have stayed away from fixed wireless access. Tarana supports near line of sight and non-line of sight deployments. So as you are broadcasting out, you're able to cover more area because you can hit the hard to reach locations as well. We have active noise cancellation and interference cancellation. It's called ABIC, where we actually place a null in the direction of where the interference source is coming from. Again, we have reused the spectrum one, so it's easier to scale a deployment and be able to support many, many customers as opposed to some of the other technologies. We can deploy our remote nodes very rapidly. And again, with the spectrum reuse, we can support more customers than other technologies that are out there. So why deploy Tarana? A lot of fixed wireless deployments that are out there shoot for 100 meg of bandwidth to a remote site. That's just where we get started. We are not happy at 100 megs. We can go up to currently 800 megabits of throughput per remote node. And later this year, we'll be able to go up to 1.6 gigabits of speed for remote nodes as well. And again, when you are deploying, you want to be able to cover as many locations as you possibly can. And with our ability to handle high capacity per sector, we can do that. We talk about 250 remote nodes in a lab environment. Most I've seen out there right now is 182 on real world deployments that are out there. Solid connections despite obstacles. Again, buildings exist, trees there, vehicles are moving constantly. So it's an ever-changing environment when you deploy a network. With Tarana's ability to do noise cancellation, it affects that and gives you better reliability on there. Also, with the ability to hit some of these near or non-line of sight locations, you can use less vertical assets out there. So you can cover more end users with less vertical assets. We constantly monitor and work with like multipathing and reflection. So what that does with intelligence, we can realign the signal so it's usable by our remote nodes and by our base nodes. That gives us more reliability, more throughput, and longer distances because we can do noise cancellation and embrace multipathing and reflection, as some of our competitors out there stay away from multipathing as much as possible. Simple installation of equipment on the remote site. I equate our remote installation very similar to a DirecTV type of install. It is very easy to install our remote nodes. We have computing power on both our base nodes and remote nodes. That allows us to align the antenna and do beamforming on both sides of the link. Also work with multipathing and reflection so we can align that signal and be able to use that. What that does is gives us, again, the ability to go over what we call passover locations, or locations that others can't hit, with our ability to hit non-line of sight and near line of sight. So again, we've talked a little bit about what some of the new technologies are out there, 802.11ax, and then the 6 gigahertz spectrum. We are coming out with a 6 gigahertz base node as soon as the FCC adopts a standard with that. Our current base node is able to deliver 2.4 gigabits per sector. The next generation is going to be 3.3 gigabits per second per sector. On our remote nodes, we are going to be able to handle up to 1.6 gigabits per second of data on there. So one of the big things with 802.11ax is it takes 160 megahertz wide channel, and there's very few of those available in the US in any location. What we're able to do is, with our new product, is use 160 megahertz wide channel, but break it down into 4 40 megahertz wide channels, where there's a lot more locations where you can actually use that. Our current product, our G1 product right now, uses an 80 megahertz wide channel. And again, it doesn't have to be 180 megahertz wide channel. It can be 2 40 megahertz wide channels. So with all the federal grant money that's coming out there, the Fiber Commission has done a great job saying that fiber broadband is the way to go on all of it. But fiber, when you're deploying fiber, is not necessarily the only solution, and it's expensive to do it. So there are times when you're deploying fiber as a backbone and you need to hit locations off that main fiber that may be 4 or 5 buildings, 10, 20 buildings, 3 or 4 miles off that fiber. And it may cost you up to $60,000, $80,000 a mile to reach those locations. So we are augmenting a lot of fiber deployments that are being put into the tribal community. So you view the fiber as the interstate or highway, and we are the side roads that are coming off of that are hitting the other areas that may not just be where the fiber is being run. We're being used to deploy many new applications out there, because what we've seen, especially in the tribal communities, there's 2 main driving factors for broadband to these communities. One is economic development, and the other one is quality of life for the community members. And telemedicine is a big driving force. Remote learning is a driving force. And there's many other applications that are out there that are being deployed, and it is driving the use of these fixed wireless networks that are being put out there. You know, closing the digital divide, digital equity. One of the most glaring inequities that has shown up during the pandemic was the ability to do remote learning. There are many communities out there, such as the tribal communities, but are similar to my family. So when the pandemic hit, instantly we had 3 people at home. 2 of us were working from home, doing Zoom calls, Teams, whatever, and 1 who was doing remote learning. But because she was a teenager, she also had TikTok going on. Because she's a teenager, we had TikTok going on to see what she was looking at. We're lazy, so we had our TV on. And what this is doing is driving the demand for bandwidth on there. And it's not only the download speed so you can watch TV or run an application or learn, but you're on a video conference and you're doing video learning, so your upload speed is very important when you're deploying these networks as well. Also, we're seeing more and more video surveillance being put on to in these communities, whether it be for traffic, or some of these sites are very remote and it's just a safety element. We're seeing them put up in gas stations, convenience stores, not necessarily inside the building, but looking out. We're seeing them in water, wastewater deployments where you are now looking at assets that the community has that they have to maintain and keep safe as well. So we're starting to see these be deployed more and more, not only in the tribal, but on a municipal basis. So everybody is starting to use this for safety purposes and first responders as well. Augmenting other wireless deployments that are out there. In a lot of the tribal communities, we're seeing a 2.5 gigahertz solutions being put out there. But it is also being determined that those solutions just don't have the bandwidth that the community needs to operate in a wireless environment. So we're augmenting those solutions out there to make sure that the community is getting the bandwidth that they need and service the community. Other reasons the tribal communities are deploying next generation fixed wireless. Public works. We've seen some for irrigation control. We've seen some for water, wastewater networks. We've seen some deployed for traffic infrastructure, whether it's cameras or radars at the remote site for traffic flow, or analytics at the intersections. They need the bandwidth. And then again, many different deployments are being rolled out for public safety reasons. Another reason they're starting to deploy out, especially 5 gigahertz, is they are broadcasting off the tribal reservations to the communities that are not a part of the tribal community, and getting a different source of revenue in for that community. They're providing foundations for new businesses. New businesses now, the ability to have broadband and the ability to have high-speed internet access is a requirement for these new businesses to grow. Providing bandwidth for precision agriculture. Agriculture is no different than any other industry that's out there. There is a huge movement for automation and getting more information so you get the most possible crops out of a field, or you utilize electricity in a economically beneficial manner. So you may be using blowers on a grain elevator on off-peak electrical hours, so you're being charged less. And you can't truly future-proof anything, but what you're doing is you're extending the life of the tribal communication networks that are out there. So 5-6 years from now, you're not having to go down and put a brand new network out there. This is a long-term solution for the tribal communities. So here is my contact information, along with Mark Billets, who is the main sales engineer that works in the vertical market. We're here to answer any questions, but again, if you reach out to your WinncOm account executives, they would be more than happy to put us in touch with you guys, and we can talk to your projects. Any questions? And give me a second, and I'll start to pull up some of these on here. So one of the questions that came in, if you deployed a 5 gigahertz network, how would it work when 6 gigahertz comes out? So all of the remote nodes are upgradable via firmware. And what that means is you would not have to replace any of the remote nodes out there if you moved from a 5 gigahertz to a 6 gigahertz network. The base nodes are a separate piece of equipment, but you can then repurpose your 5 gigahertz into a different part of your network that works better for you as well. Second question is, some of these areas are remote and don't necessarily have fiber now. Can you connect these using microwave backhaul? And the answer is yes. We're doing a ton of last mile deployments with microwave as our source of internet access to that. Next one is, how do I determine if I'm a candidate for funding or even a Tarana network? We would be more than happy to work with you to do heat maps and do feasibility studies with that as well. We are rolling out a tribal program that should be out within the next couple of weeks, where we can help you get in touch with third-party grant writers to help write your tribal grants as well. Are there any other questions that are out there? That's the ones that came in. I'll give you guys a second here to see if anything comes up. All right, I don't see any other questions coming in, but if you're like me, as soon as the webinar's over, everybody will start to have questions. Again, reach out to your WinncOm account executive, and we would be more than happy to answer those questions. Thank you very much for your time today. Look forward to talking to you in the future. Bye.